Hey guys, today we are going to explore AI features which we could deliver to our users, including natural language as a control. Imagine if your application could be controlled by the natural language through the text or voice. How it could look like? Well, let's take a look on this app. So basically this is the list of Harry Potter characters, and it could be filtered. So for example, I could find all the half giants in this list, like Hagrid, for example, or I could create some more complex filters, like let's create all the humans. They should be female and they should be from Gryffindor. Yeah. So as you can see, the application works. But what if I would be able to do this with my voice or text? Something like this: show all humans, and after that the app could proceed this text and apply something. So at the moment this feature doesn't work in this project. As you can see, there is nothing in the applied filter, but it is possible, and I'm going to show you how. Well, first of all, let's explore the structure of this project a little bit. Basically, I have all the characters as structures with multiple fields. Some of them are strings, some of them are booleans, some of them are enumerations, like this: species, ancestry, gender, and house. Also, I have a filter as a structure, which combines all these fields all together. So here I could specify all these pieces which I'm looking for: genders, houses. I could also provide Boolean flags for stuff like is character wizard or not, is he a Hogwarts student or not, is he dead or alive, and so on. And then this filter is used by the app to filter all the results to a much smaller list. And at the moment I have this pop-up input view model, which does nothing when its button is tapped. Basically it just waits for 1 second and then applies a no filter over there. So how this could be modified? We are going to use the new framework named FoundationModels, and we are going to import it first to the filter structure. So I would like the application to be able to generate filter as a result of some operation, and for that I'm going to use the generable to mark the structure as being able to be generated by the language models. But it also means that all the subtypes which are used in this should be also marked as the generable. So let's do this for species, let's do this for ancestry, for gender, and for house. Good. So we have this, but it is, I would say, not enough. Actually, we are able to provide guides for every field in the filter. So, for example, a good one would be for species, would look something like this. Species, the character must be one of multiple values combined as or, leave empty when the user did not constrain species. So bear with me while I will finish all the guides for other fields. So it's going to be genders, it's going to be the guide for the houses, the guide for his wizard, the guide for ancestries, the guide for his Hogwarts student, the guide for his Hogwarts stuff, and the guide for is alive. All right, so now we have the guides for all the fields in this structure. So where we could generate this? Let's go to the input view model and also import the foundation models over here. So to use the language models on the iPhone, we would need to use the special objects named language model session. You could create it as is, but it is better actually to provide some instructions for this model. Let me copy and paste some basic model which I came for this. All right, so let's inspect these instructions. So basically at the top we have a main goal of this model. You translate a user natural language request into filter, the structure, yes, that selects Harry Potter characters from a fixed dataset. Then I am explaining the fields like species, genders, houses. These are arrays of enum values. Is wizard, is Hogwarts Susan, is alive, is Hogwarts staff, is a boolean. And also I am explaining some rules over here, like only set fields that the user explicitly asked about. So there won't be set any other filters which are not related to this particular prompt the user wrote. And the fields are combined as and. Then some vocabulary like alive and still alive should be applied as is alive true, or for example dead, deceased and killed, it means is alive should be false. Something about house names and the examples. So we have this session, and finally we are able to create some requests to this session. So let's do it over here, like let response. For that we are going to try wait session respond to our prompt, and it's going to be generating the filter type. And after that our response is going to contain a filter in its content because basically response is a generic structure. All right, so we have everything in place. Let's actually test this. I am going to test this on actual device because, well, otherwise my Mac wouldn't be able to handle this. So I am going to run it on my iPhone. So it is loading. Right. So let's do some simple requests. Something like show all humans. And let's check for the results. So as you can see, there are no results, and the answer for that is that, yeah, it set all the humans, but it also set a lot of other filters, as you can see. So that's why the list was empty. So as you can see, the language model didn't do its job properly. So what we could do about this? The most obvious answer is that we should work harder on our prompts and guides. Let's actually go to the filter guide, and over here we could enrich our guides specifically for the default cases. So for example, for the species I would put something like do not enumerate every species to express any species, use empty array instead. We could do something similar for the genders, right? And now let me actually fill all the other guides and enrich them a little bit. So the next one is the houses. So do not list all 4 houses as default. Then we are going to enrich the isWizard. That it must be nil if it is not mentioned. Then we are going to clarify the ancestries, right? Then we are going to clarify the is Hogwarts student. Then we are going to clarify the must be nil when the user didn't mention staff or teachers. And finally, for the dead and the alive people, yeah, it must be nil when no content is provided, and so on. So as you can see, I've enriched every guide. Now it explicitly tells the model what to do whenever there is no value specified for any particular field. So we could rely on these guides now. And also let's do something with the instructions which we gave to our model. Let's keep the basic instructions as is. So the model still should translate a value natural language request into a filter. But let's replace everything else in this guide. All right. So what changed? Here I explicitly specified that there is some critical stuff. The filter is a list of constraints, not the description of the results. A field that is not constrained must stay at its default. Like for the arrays should be empty. Optional Boolean fields by default should be nil. What the defaults mean? Then it means that an empty array does not mean nothing. It means do not constrain this dimension. Every value passes. Do not enumerate every num case to express any. Use empty array, and so on and so forth. Also, I am specifying the settings rules, like only set a field when the user explicitly mentioned the corresponding concept in the prompt. Values inside one array combine as OR. Fields you do set combine across the filter as AND. Again, some vocabulary, and again some examples. Much more examples as we had before. All right, so let's build this and let's test how it works. Okay, so let's use the similar prompt. Show all humans. Again, now we are going to wait a little bit. So it shows something. Let's actually check for filter. Yeah, it shows the humans. But again, as you can see, well, it selected some other filters which I didn't actually ask for. All right, so this didn't work either. So I think that we need to change the concept of the filter and the filter request. Basically, instead of just constraining the filter, let's focus a little bit on the filter constraints. Well, first let me remove all the guides, and also, as you can see, the filter is not going to be generable anymore. So yeah, all this is removed. So my idea is that we should have some enumeration like this, the filter constraint, and the filter could be combined out of this constraint. So let's create the new structure named filter request. It's going to be generable. It's going to have all the constraints over here, and also we would be able to create filter out of these constraints using the computable property. So how it works, you can see on the screen that we are starting with the empty no filter, going through the array of the constraints, and depending on the constraint, if it is, for example, species, gender, house, or ancestry, then we are appending this particular value to the array inside the filter. If it is some Boolean value, then we are just resetting it to the expected one. This is going to be the generable structure, so it needs some guides. What worked for me is guide something like this. One entry per dimension, the user explicitly named in the request. Emit 0 entries when the user named no constraints, like show everyone. Do not add a constraint for any dimension the user did not mention. All right, now let's go back to our model, and we are going to replace the instructions over here. So let me quickly copy and paste this. Nice. So again, as you can see, the main instruction is still the same. Basically, we're explaining that the model should translate a user natural language request about hypothetical characters to a filter request, a list of constraints. So what I put here, that there are two main jobs for this session. First is emit one constraint for every concept the user named. Compound requests like female humans into two constraints. Do not stop after first concept, scan the entire prompt, and translate every descriptor. And finally, another job is to keep the filter request minimal. So do not invent constraints for dimension the user didn't mention. Again, there is some explanation on how filters work. The constraints across the list combine as AND. There is some vocabulary over here. And of course, there are some examples. Over here, in our respond, we should replace the type of generated structure from filter to filter request. And now we are able to access the filter request and generate filter out of it as a computable property. All right, so we have everything in place. Let's test the new build. Okay. Okay, looks like everything is in place. Let's ask it again to show all humans. And well, it set the human. Finally, no other filters are applied. Now let's clarify that again and ask to show female humans. Would it be able to work with this. So it set the human, it set the female. So this is exactly what we wanted. And probably we could enrich the request even further, like show dead female humans. Oh, look at this. Yeah, all the filters are applied exactly as I wanted. So, and this is it for today. I hope you enjoyed this video. If you would like to know more about the foundation models, then put your questions to the section below. You would be able to find this exact repository as a link in the description of the video. And see you next time. Cheers!